This is Ed Robinson of Kensington College. Today we'll be talking about structures. This is a structure. It's used to hold data, but it's used to hold data of different types. We could hold an integer, or we could hold a character, for example, or a string, and so on. We've already come across, we haven't actually, in an array. An array is used to hold, let's say, for example, integer values, or an array called whatever is used to hold text or string values. But the important thing about an array, as you see here, which we'll be dealing with later, is that it can only hold one particular data type at a time. For example, it can only hold integers or only hold strings. It can't have a mixture. So let's see how we make a structure in C#. Outside main, we can declare our own structure using the struct keyword, and then we call the structure anything we like. For example, part, any arbitrary name that you'd like to give your variable. Then we use curly braces. We must always have curly braces. Sometimes some people might think we put a semicolon at the end, which we do in C++ and C, but we don't. There's no semicolon after the struct. So this is the container, if you like, a declaration. What we're going to do then is to place some declaration of types within the structure. Here we have an integer type and a character. You'll notice that the declaration is public. That is to say, it's going to be accessible from outside, and I'll show you what you mean by that in a moment. We then create an instance of the type. For example, part P1 means that P1 is going to be an instance of type part. Part, of course, is the name of the structure. It's green at the moment because it means it hasn't been used. Never mind, we will in a moment. So you could call this like P1 or part 1 or X or any old variable that you like. Then how do we access the data? For example, we might want to set the I equal to 2, so we type P1, and you'll notice the drop-down appears saying that I is a variable. So we put that equal to 2, for example, and we do the same thing for the other. So P1 dot, we can see here we've got an S, which is the character, so we can put that equal to some character. Don't forget our semicolon at the end. So this is how we set the data. We call this public access because we are accessing here, using the dot operator, we are accessing the data inside the structure, which is public. That means to say it's available from outside. Public means that we can actually use this type of notation to access the data. But just the same as we can set the data, we can get the data as well using the same dot operator. For example, if we want to write it out to the screen, the values of I and S, then we can do that. So we can build this program and then run it. Build successfully, so we can run our program, and you can see the output is 2 and I using the right line, and we've output that to the screen, the value of I and the value of S. You can see that this struct is more or less a template for your data, which contains integer and character at the moment. If we were to just run without initializing the variables, well, it won't actually. It says here, let's try and build this. It's complaining about these values here. But it is interesting if there is another way of creating an object, and that's by using the new. This is just an alternative that you may include as well. But in this case, what happens is that a constructor is called. Now what what is a constructor? A constructor is something which is called whenever we create an object like this, or an instance, and initializes the variables. So if we build this and run it, well, first of all, it's not complaining as it was, so that if we build and then run, it's warning us that it's not assigned. But when we run it, you'll see that, well, at least the I has been initialized to 0, and it looks like some sort of blank character is the initialization of S. So basically what I'm saying is that there are two ways to initialize your instance. Well, and one was just part P1, semicolon. On the other hand, we can use the new keyword. It's probably easier for the moment just to use this part P1. But just take an idea of what we're doing here, that part is a type, just like int is a type. So when we say int I, we are declaring I to be of type int. But in the case of when we declare part, we're declaring it part P1 to be of type part. And what's part? Part is a user-defined type, a type that we have defined here. To get use of structures for yourselves, you might like to try this exercise at the moment. Make a structure called stock. We had as was called part. Let it have member values dt and pr for price, which are string and double respect. We haven't really come across string much, but we just declare our variables as string dt for the moment. So in order to do that, we could create our structure like this. Stock is the type that we'll be using. We should now put in some, you can try this if you pause the video and see how you might do it to introduce your variables. So we can declare the variables as a string, as the date, and then now how would we actually go about creating an instance of this? By using the type and a variable, and we could therefore create our instance of stock. We could then define our instance variables. For example, for S1, you can see that we'll have dt, which is available, so I'll choose dt and then put that equal to some date. Well, that's just a string, it's not really a date type, or maybe use a date type later on. Don't forget the semicolon. And then what about defining a value for the other variable, which you can see is available here, the pr equals, we'll make that some arbitrary value. So we have initialized the variables of one instance. We could just repeat this basically to make instances of S2 and S3, which I'll do here. So we've got, as you can see, creating another instance which is named S2, another instance S3, and we're putting our initializing our variables within the structure instance. Having initialized the data for each stock, then we might want to print them out, for example, using something like this. S1 was purchased, and we use a placeholder here for S1 dt and the other placeholder here for S1 PR. We could just see if that works for a start. So it's worked for one of them. S1 was purchased on the first at a price as such. Well, we could easily just stop our program. You could do that for the other two if you like. I'll leave you to do that. Just S2 and S3, and these need changing. S2 Now if we just run that, we have all three purchases. Just as a variation on this, instead of making a string, you might like to make that a date time type. That will allow you to sort dates and that sort of thing. And the way we would initialize our date is like this. So I'll just leave that there for the moment so you can compare them, but basically we'll delete this, and this is the way we would specify our time, but that's just incidental. Let's return to our original structure named part, and we created some instance called P1, and we made some data. We set some data, and then we printed out some data. So when we ran that, it printed out the 2 and the A. Here we've initialized our data. There is another way of initializing data, and that's by using a constructor. What is a constructor? A constructor is something which is called, a method, which is called whenever a new object is created. So what we're going to do in here is put our constructor. And the constructor, as I just said, is something which will get called whenever we create a new object. But the notation that we must use new if we're going to use this constructor, use a constructor. So now we actually make our constructor and place that in our structure part. You can see it's a public method. We'll come to methods later on, but method is a function which is called. You can see that we're called whenever we create a new instance of P1, then we are passing these two values to here and here. We're going ahead a little bit. We haven't really talked about functions, but for the moment, just remember this general structure. This means the current object which has been created, which is like the internal object. This I is the I which belongs to the object. I think we really need to talk more about this when we talk about classes. So just a moment, just bear with it. We shouldn't really use I as we should use perhaps underscore I in here, but that's the general idea. So we don't need this anymore, so I'll either delete it or comment that out. But that does an equivalent job. It initializes. So this does an equivalent job. It initializes the 2 and the A. So if I build this and run it, you will see that it performs exactly the same as previously, giving us the values 2 and A. But this time we've used a constructor. What about the no parameter constructor? So if we were just to create an object but make our own constructor here, which has got no parameters, so if I were to delete that and here I need to initialize, for example, I is equal to 2, we're going to initialize inside the constructor, and S is equal to A inside the constructor. And that looks fairly legitimate, but you can see it's complaining, and it says struct cannot contain explicit parameterless construction. So it just won't allow you to do that. It seems a little strange to me, actually. If you find this talk about constructors a little daunting, I think really we ought to defer this until we talk about classes. So you could just persevere without using constructors.